And thus we begin our series on the mole. Not the furry little critter that's tearing up your yard, but the counting unit of chemistry. This is a counting unit, is what this is. Excuse me. Bakers use a dozen. 12 donuts is a dozen donuts. Chemists use a mole. And the number that is always referred to is this one down here in the corner. 6.02 times 10 to the 23rd things. This is Avogadro's number. So important is this relationship that we have an entire day to celebrate this concept in October. October 23rd, from 6:02 in the morning to 6:02 in the evening. So great is this day, it kicks Pi Day's butt because we have food and flaming things and explosions. It's great. All right, so first thing, let's talk about our mole conversions. This is the beloved mole map. It is just that. It is a map of molar conversions. Let's see if I can get the whole thing. There we go. All right, guess I'll have to do this one piece at a time. So, our mole, it is in the center. Anytime we want to convert to or from a different type of measurement, a mole is what we use in our relationships when we're talking about stoichiometric calculations. How much of a product will I get when I mix these two things together? The molar relationship is what allows me to do that, but I can't measure that. I have no stick or graduated cylinder or scale that calculates moles. So instead, you would have to calculate particles, volume, or mass, and then convert to moles. So this is a conversion, just like the conversions that we did in Unit 1 with my kiddies in my class. We have conversion factors just like before. Anytime you want to convert from between volumes and moles, this branch here, you're going to use this conversion factor. 22.4 liters equals 1 mole of any gas. Let me write that down. Any gas at STP, standard temperature and pressure. Can you see that? No, you can't. There we go. So STP, standard temperature and pressure, is 1 atmosphere and 0 degrees Celsius, which is 273 Kelvin. So any gas that you're talking about, any one at all, we assume it to be an ideal gas at standard temperature and pressure, and it has a volume, 1 mole of it has a volume of 22.4 liters. If I were talking about particles, this branch over here, if I were converting between moles and particles, I would use this conversion factor, Avogadro's number. Avogadro's number. There we go. 6.02 times 10 to the 23rd particles equals 1 mole. Now, particles just stands for individual things. You could be talking about atoms, or molecules, or paper clips, or potato chips, or kumquats, or pink elephants. I don't know. Anything at all. Any individual thing is what particles can stand for. The bottom leg here, between mole and mass, our conversion factor between those two is what's known as the formula mass. And the formula mass is nothing more than the masses on the periodic table added together. If you have 1 mole of a substance, it will have the same mass in grams as 1 atom of that substance has a mass in AMUs. So, for example, periodic table tells me that chlorine has an atomic mass of 35.45 AMUs. Well, 1 mole of chlorine, if it was just Cl, bad example, would have a mass of 35.45 grams. If I were talking about tin, if I had 1 atom of tin, it would weigh 118.71 AMUs, in case you don't believe me. If I had 1 mole of tin, it would weigh 118.71 grams. So if you had a compound, add them all together, that's how you get the formula mass. So your formula mass is the mass of 1 mole of your substance. For now, we're going to concentrate on this leg right here. I'm going to show you a couple of examples on this leg right here. And then the next videos, subsequent videos, will cover the other 2 legs and even the new superhero in town, multimole. Yes, I am that corny. Okay. Particles. So, For example, let's say that you want to convert 4.89 times 10 to the 23rd atoms of sodium into moles of sodium. Remember, the capital E is the same thing as times 10 to the same thing. And this is a conversion. Here's my starting unit. Here's my ending unit. I need something that relates the two things. Oh, look. Particles, moles. Just what I wanted. So I know that 6.02 times 10 to the 23rd atoms of sodium equals 1 mole of sodium. Can you see that? Yes. My starting unit is present. My ending unit is present. I'm good to set up my boxes. Upper left-hand corner always goes the number that the problem has given you. Add in the unit. Make sure you have your unit. And just to make this nice and simple, you always put your first number over 1 so that everything has a top and bottom. Sometimes that's hard to remember, so I always just say to draw a smiley face, just to remind you that nothing of interest goes there. I have atoms on the top. I want them to cancel. I don't want them anymore. Here are atoms next. 6.02 times 10, 23rd. Atoms. I use the first part of my conversion factor, blasted flour. I cannot move forward until I use my entire conversion factor. So on top of 6.02 times 10 to the 23rd atoms goes 1 mole. The other half of my conversion factor. Remember that the top and bottom, must be true. They must be equivalent, equal to one another. So now we're going to multiply all the way across the top. Yes, I'm doing this the long way. Divided by all the way across the bottom. And let's see what my calculator gives me on that. 4.89 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. Notice I'm putting these in parentheses. It's a good habit just because that tells your calculator that this is one thing. And we get 0.81229. We'll stop there. So the last thing I need to consider before I move on is I need sig figs. According to our rules, constants and conversion factors like that, like our 6.02 times 10 to the 23rd, have an infinite number of sig figs. So the only thing that affects my number of significant figures is the number that my problem gave me originally. 3 non-zero digits, 3 significant figures. 1, 2, 3. That's as far as I can go. 0.812. Now, something to be careful of whenever you're doing molar conversions is you need to make sure that your answer includes the number, the unit, whoops, my camera and this thingy are unaligned for some reason, and the thing. Number, unit, and thing to have a complete answer in anything dealing with moles or compounds or anything like that. Number, unit, thing. I always say Newt. Apparently, I have an Egyptian thing. I don't know. Egyptian goddess Newt, goddess of the night, if memory serves. I got nothing. Anyway, let's try another one. This one, I'm going from moles to individual items. So again, I'm going to use my same conversion factor, 6.02 times 10 to the 23rd. This time, my individual particle are Skittles, is 1 mole of Skittles. Ending unit present, starting unit present, good to go on the boxes. 9.85 moles. Skittles will abbreviate with an S. It's really a good habit to do your Newt in each box, because you'll have to do that once we get to stoic and we start converting between substances, and this gets a whole lot more complicated. Smiley face on the bottom. Moles on the top. I don't want moles anymore. I want them to go away. There we are. 1 mole. I use that piece. Cannot go forward till I use the whole thing. 6.02 times 10 to the 23rd Skittles goes on the top. So I use that piece. Moles on top, moles on bottom, cancel. Woo! Now I'm going to multiply all the way across the top. 9.85 times 6.02 times 10 to the 23rd. And I get 5 point... How many sig figs can I have? 3. 5.92 times 10 to the 24th, so that's 5.93 times 10 to the 24th. There's my number that you can't see. There's my number. My unit happens to be Skittles. And it is also my thing. So this one, those two get combined. So here is my final answer. Hopefully that is enough examples for now. Happy converting.